Hello dear students, I am Sunil Kumar, lecturer physics working in Government Senior Secondary School, Kalanangal. Dear students, today we will discuss a topic of chapter Wave Optics. In the introduction of the topic, see these beautiful flowers, they have different colors. The cause of their different colors can easily be explained by the reflection and absorption phenomena. The corpuscular theory easily explains these phenomena. But the colors of the feathers of a peacock and the colorful pattern on the layers of soap bubble cannot be explained on this theory of ray optics. So my topic is Huygens principle and its use to prove law of reflection and law of refraction of light. Wave theory of light was given by Christian Huygens in 1678. In the learning objective, we will learn number 1, wavefront, number 2, spherical, cylindrical and plane wavefront, number 3, Huygens principle, number 4, law of reflection, number 5, law of reflection on the basis of Huygens principle, number 6, law of reflection. Number 7, law of refraction on the basis of Huygens principle. First of all, wavefront. When a ball is dropped in water, waves spread in all the direction in the form of concentric circles. Every concentric circle is associated with crest or a trough. If we consider a concentric circle, all the points will oscillate with same phase. This is because they are at same distance from the point of impact. A locus of all these points which oscillate in the same phase is called wavefront. So, write the definition of wavefront: the locus of all the particles of medium which are vibrating in the same phase at any instant of time is called wavefront. The phase difference between any two points on the wavefront is 0. Let us discuss some important points about the wavefront. Number 1, wavefront is defined as locus of all points having same phase at a given instant. Number 2, the shape of wavefront depends on the shape of source of disturbance. Number 3, a wavefront is normal to the light rays. Number 4, a wavefront does not propagate in the backward direction. Types of wavefront. There are 3 types of wavefront. Number 1 is spherical wavefront. Number 2, cylindrical wavefront. Number 3, plane wavefront. Let's discuss spherical wavefront. In the diagram, P is a point source. All the wavefronts spread in all possible directions in the form of concentric spheres. when the source of light is a point source, the wavefront formed will be spherical wavefront. Point source means the source of light is so small that it is considered as point. It can be considered as dimensionless. For example, ripples in the water are in the form of concentric circles, which are similar to a spherical wavefront. Cylindrical wavefront. In the diagram, it is clear that when a source of light is a line source, cylindrical wavefronts are formed. When the source of disturbance is a slit, that is line source, then the wavefront is cylindrical because all the points are equidistant from the source and they lie on the surface of the cylinder. Plane wavefront. When the small part of a spherical or cylindrical wavefront originates from distant source like infinity, then the wavefront which is obtained is known as plane wavefront. For example, rays coming from infinity like sun, because sun is at very long distance from our earth, so we get plane wavefront on the surface of earth. Huygens principle. In the diagram, S is a point source. All the waves are traveling in the form of spherical wavefronts in all possible directions. Let AB is a primary wavefront at any instant of time. Every point on this wavefront acts as a new source of disturbance. So, spherical wavefronts are formed, which are shown by the numbers 1, 2, 3, 4 and so on in the diagram. Draw tangents A1, B2 and A2, B1 on these spheres. These tangents are the secondary wavefronts, but the wavefront in the backward direction is not possible. So, wavefront A2, B1 is not possible. When we are at a very long distance from the source, we get a plane wavefront as shown in the diagram. At the same time, it is clear from the diagram that rays of light are perpendicular to the wavefront. So Huygens principle states that each point of the wavefront is the source of secondary wavelets, small waves which spread in all directions with the speed of wave. The new wavefront is formed by drawing a line tangent to all the wavelets. Law of reflection. In the diagram, an incident ray is striking a mirror and we get a reflected ray. The angle between incident ray and normal is called angle of incidence, and the angle between reflected ray and normal is called angle of reflection. Law of reflection states that when a ray of light reflects off a surface, the angle of incidence is equal to the angle of reflection. That is, angle I is equals to angle R, as we have seen in the diagram. Law of reflection on the basis of Huygens principle. Consider a reflecting surface xy. Let AB is an incident plane wavefront, incident at an angle I with the speed v in air. In the diagram we see that AB is a plane wavefront because source of light is at infinity. Incident wavefront, which is a plane wavefront, is incident at an angle I. Mathematically, angle BAY is also I. If tau is the time in which incident plane wavefront travel from B to C, then BC equals to V tau. In the diagram, incident plane wavefront AB is traveling from point B to C in time tau. Therefore, the distance BC equals to speed multiplied by time, and we get V tau. So BC equals to V tau. Take A as center, V tau as radius, draw a wavefront. In the diagram, we see that A is a point on the reflecting surface xy. Take A as center and V tau as radius, draw a spherical wavefront. Draw a tangent CE on the wavefront from point A. Also, the time in which incident wavefront travel from B to C is equal to time in which reflected wavefront travel from A to E. So AE is equal to BC is equal to V tau. In the diagram, we see that there are two triangles AEC and ABC. Both the incident wavefront and reflected wavefront travel in same time, and these wavefronts are also traveling with same velocity. Therefore, distance BC and AE both are equal and equal to V tau. In triangle BAC, sin I is equals to BC over AC because sin theta is equals to perpendicular over hypotenuse. In the diagram, we see in triangle BAC, sin I is equals to BC over AC. Let this equation be number 1. Similarly, in triangle EAC, sin R equals to AE over AC. Let this equation be number 2. Dividing number 1 by number 2, we get sin I divided by sin R is equal to BC over AE because AC get cancelled on dividing the equation 1 by equation 2. Put the value of BC and AE. BC equals to V tau and AE is also equal to V tau. So we get sin I over sin R is equal to 1. On cross multiplying, we get sin I is equals to sin R. Therefore, I is equals to R, which is the law of reflection. Therefore, Huygens principle successfully explained and proved law of reflection by using wave theory. Law of refraction. In the diagram, we see that an incident ray is traveling from rarer medium to the denser medium. Let I is the angle of incidence. Angle of incidence is the angle which incident ray makes with the normal. In the denser medium, refracted ray makes angle R with the normal, which is called angle of refraction. Angle of refraction is the angle which the refracted ray makes with the normal. Since light is traveling from rarer medium to denser medium, that is why it is bending towards the normal. Law of refraction states that the incident ray, refracted ray, and the normal to the interface of two media at the point of incidence all lie on the same plane. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant. Therefore, sine I over sine R is equals to refractive index of denser medium with respect to rarer medium, or refractive index of second medium with respect to first medium. Relative refractive index is equal to mu2 over mu1, which is equals to v1 over v2. Therefore, relative refractive index is the ratio of speed of light in the first medium to the speed of light in the second medium. Law of refraction on the basis of Huygens principle. In the diagram, we are seeing two mediums, medium 1 and medium 2. Medium 1 is a rarer medium and medium 2 is a denser medium. Let v1 is the speed of light in the medium 1 and v2 is the speed of light in the medium 2. Both the mediums are separated by an interface xy. So, write, consider two media 1 and 2 separated by a boundary xy. Let v1 and v2 are the speeds of light in the two media. Let a plane wavefront AB incident on it at an angle I on the interface xy in the medium 1. From the diagram, it is clear that AB is an incident plane wavefront because source of light is at infinity, or it is at a very large distance. The incident wavefront is incident on the interface of two media in the medium 1. Let the incident wavefront AB travel from B to C in time tau. Therefore, BC equals to V1 tau. From the diagram, it is clear that incident wavefront AB is traveling from B to C in time tau because V1 is the speed of light in the medium 1. Therefore, BC equals to V1 tau. Also, the angle BAC is equal to I, which is the angle of incidence. Take A as center, V2 tau as radius. Draw a wavefront. Draw a tangent CE on the wavefront such that AE equals to V2 tau. In this diagram, AB is an incident wavefront and CE is a refracted wavefront. Both are in the same phase, but in case of reflection, incident wavefront and reflected wavefront are out of phase. They differ by a phase of pi radian. Let r is the angle of refraction. From the diagram, angle ACE is equal to r. Therefore, CE is the refracted wavefront. In triangle BAC, sin I is equal to BC over AC. Let it be equation 1. Similarly, in the refracted region in triangle EAC, sin R equals to AE over AC. Let it be equation 2. On dividing the equation 1 by 2, we get sin I over sin R is equal to BC over AE, because AC and AC get cancelled when we divide the equation 1 by 2. Since BC is equals to V1 tau and AE is equals to V2 tau, therefore we get V1 tau divided by V2 tau. Tau and tau get cancelled, therefore sin I over sin R is equal to V1 over V2. Therefore, sin I over sin R is equals to relative refractive index of second medium with respect to the first medium, which is Snell's law or law of refraction. Therefore, Huygens principle successfully explained and proved the law of refraction by using his wave theory. Recapitulation. Question number 1. What is the shape of wavefront diverging from a point source? Number A option is cylindrical. Number B is spherical. Number C is plane wavefront. Plane. It is clear from the question that source of light is a point source. So the wavefront formed is spherical. So right answer is option B. In the second question, how is the wavefront to the direction of corresponding rays? Option A is in the direction of ray. Option B is at an angle of 45 degree. Option C is perpendicular to the direction of rays. We have discussed in this topic that a wavefront always acts at a right angle to the ray of light. Therefore, right option is C, perpendicular to the direction of ray. Third question, what is the phase difference between any 2 points of a wavefront? In a wavefront, all the points lie in the same plane. So, there are 3 options: angle A equals to 0 degree, B equals to 90 degree, C equals to 45 degree. Because all the points on a wavefront lie in the same plane or in the same phase, so option A, 0 degree, is the right answer. In the fourth question, what is the nature of a wavefront when source of light is at infinite distance? When source of light is at infinite distance, we get spherical wavefront. So out of the 3 options, cylindrical, spherical and plane wavefront, B option, spherical wavefront, is the right answer. Question number 5. According to Huygens principle, light is a form of, A option is particle, B rays, C option is waves, and D none of these. In this question, the right answer is wave, because Huygens successfully explained the wave nature of light. In question 6, light propagate rectilinear because of its A option is particle nature, B option is frequency, C option is wave nature, and D is wavelength. Light propagate rectilinear because of its wave nature. So right answer is C. In the 7th question, when a wave undergo reflection from a denser medium, then there is a phase change of A option is 0 degree, B option is pi radian, C option is pi by 2 radian. In reflection, incident ray and reflected ray differ in phase by pi. So B is the right answer. In question 8, when a wave undergo refraction, there is A option no phase change, B option change of pi, C option change of pi by 2. In refraction of light, incident wavefront and refracted wavefront are in the same phase. So right option is A, no phase change. Dear students, we easily understood Huygens principle, law of refraction and reflection of light by using the Huygens principle. So take care. Thanks.